These are the notes for section 6.2 and 6.3, properties of parallelograms. Objectives are, I will be able to recognize and apply properties of the sides, angles, and diagonals of parallelograms. I will be able to recognize the conditions that ensure a quadrilateral is a parallelogram, and I will be able to prove that a set of points forms a parallelogram in the coordinate plane. So we have to first say what a parallelogram is. A parallelogram is a quadrilateral with both pairs of opposite sides parallel. So remember these two lines here, that's our symbol for parallel. So if I would want to do this, I would make a couple sets of triangles to show that the opposite sides, both pairs, are parallel. So here are some properties of parallelograms. So we can use the definition. We can say both pairs of opposite sides are parallel. So again, it's just the same thing we did before. We label them with these colored in triangles to show that they're parallel. Both pairs of opposite sides are congruent. So hopefully you all remember that the one tick mark means that AB and DC are congruent, and the two tick marks mean that AD and BC are congruent. Both pairs of opposite angles are congruent. And we should all remember that the congruent symbol is the equal with the tilde over it. So what we mean by opposite angles is A and C. They're on opposite sides of the parallelogram. And also angle D and angle B are going to be congruent. Both pairs need to be congruent for it to be a parallelogram. Each pair of consecutive angles is supplementary. Remember, that meant they add up to 180. So the measure of angle A plus the measure of angle B. These are consecutive angles because they are next to each other. A and B are to the right and left of each other. That's equal to 180 degrees. Another pair of consecutive angles is the measure of angle B plus the measure of angle C. They equal 180. The measure of angle C plus the measure of angle D is equal to 180. And I guess I'll do it over on the left side here. The measure of angle D plus the measure of angle A is equal to 180 degrees. So those are each pair of consecutive angles are supplementary. So number 5 says the diagonals of a parallelogram bisect each other. So our diagonals are DB and AC. They bisect each other, so that means that AC is congruent to CE, and segment DE is going to be congruent to segment BE. The last property we have is one pair of opposite sides of a quadrilateral is both parallel and congruent. So an example of this would be where AB is parallel to DC and AB is also congruent to DC. So those are our properties of parallelograms. A lot of them you can really draw a parallelogram and they make sense because they're very visual. So it might seem like a lot to remember, but they're very visual. You can tell just by the pictures, or you can kind of guess by the pictures what's going to be congruent, what's going to be parallel. The diagonals look like they bisect each other. So really nothing should be that surprising. Let's go over some examples, though. We have quite a few. So we have the parallelogram DECK, and if we're told that DE is 10, so it's right here, KC has to be what? So remember, parallelogram opposite sides are congruent, so that means KC has to be 10. So let's erase this. If DC is equal to 18, what does DT equal? Well, we need to remember that they bisect each other, so that means they would both have to be 9. DT would be 9 and CT would be 9. So number 3 says the measure of angle EDK. So EDK. So this whole angle here is 100 degrees. And we need to find ECK. So we need to find what that is. So we need to remember that opposite angles are congruent. So that means it's going to be 100 degrees. If I look at number 4, I'm told that the measure of angle DEC is 75. So DEC is 75 degrees. And we're asked to find KDE. These are consecutive angles, so that means they have to be supplementary. So it's 180 minus 75, which is 105 degrees. They have to be supplementary. So let's move down to the second picture for number 5. We're told that the measure of angle 1 is 30 degrees. The measure of angle 2 is 40 degrees. And we're asked to find the measure of angle 3. So you have to remember a little something about parallel lines to figure this one out. So remember that KC and DE are parallel. So if I have this line here, which is a transversal, angle 1 and angle 3 are alternate interior angles. Whenever they're alternate interior angles, let's see, I'm not there yet. I'm actually doing number 6, which we can do. When they're alternate interior angles, they have to be congruent, so that means angle 3 has to be 30 degrees. If I go to number 5 now, sorry to move out of order. If I want to find KCE, I need to know that 30 and 40, which this whole angle here is going to be 70, has to be supplementary with KCE. So that means it has to be 110 degrees. So things are looking pretty complicated with my picture. So we'll erase it. When we just did in blue, remember, consecutive angles, supplementary. So number 7 says if the measure of angle 3 is 36 degrees, and the measure of angle 2 is 44 degrees, what is the measure of KDE? Well, by that same argument, I know that angle 1 is 36 degrees. So the measure of angle CKD is equal to 36 plus 44, which is 80 degrees. So this whole thing here is 80 degrees. So I'm asked to find KDE, which is right there. It has to be supplementary. So it's 100 degrees. Number 8, I guess we'll move down to the third picture. It says if DT is 7 and KT is 9, then CD equals what? So if this is 7, I know that this has to be 7. So all the way back in the beginning of the year, we learned about the segment addition postulate that says CD has to be 14, which is 7 plus 7. We don't need this KT equals 9 in order to solve this problem. Let's take a look at the next one. We're told DE is 5x and KC is 3x plus 12. We're asked to solve for x. So opposite sides of a parallelogram are congruent. Therefore, we have 5x is equal to 3x plus 12. When I subtract 3x, 2x is equal to 12. When I divide by 2, I'm going to get x is equal to 6. Number 10 says ET is equal to x plus 3. And EK is equal to 22. So that's that whole thing here is 22. So let me make that a little clearer. So if ET is x plus 3, that means KT has to be x plus 3. So we could say x plus 3 plus x plus 3 is equal to 22. Combine like terms, we get 2x plus 6 is equal to 22. Subtract 6. 2x is equal to 16. And lastly, divide by 2. We get x is equal to 8. A couple more examples to go. Number 11 says if angle KCE, so that's this one right here, is equal to 6y minus 20. And EDK is 2y plus 80. What is y? We solve this by setting them equal to one another. Because we know that opposite angles are equal. So I add 20 to both sides. I'm going to get 4y is equal to 100. And y will equal 25. The last problem is number 12. Told that the measure of angle DKC is 7x minus 6, and KCE is 4x minus 2. So we know those two angles are supplementary because they're consecutive. So we get 7x minus 6 plus 4x minus 2 is equal to 180. Again, consecutive angles are supplementary in a parallelogram. Combining like terms, I get 11x minus 8 equals 180. So I paused the video for a second. I saw I made a mistake in copying down the problem. This right here is a plus, not a minus. So whenever we do that, we should end up with 11x plus 4 is equal to 180. So sorry about that. So we take 176 divided by 11. And we get x is equal to 16. So hopefully all of these examples reinforced different properties that we had. Both sides of a parallelogram are parallel. Both opposite sides are congruent. Both opposite angles are congruent. Consecutive angles are supplementary. Diagonals bisect each other, and it's a parallelogram if one side is both parallel and congruent. So again, we're going to be working with more properties here for 13 through 18. Because I want you to get some practice in on your own, I'm only going to do the even-numbered problems. So we know that DE has to be congruent to GF. Why? Opposite sides are congruent. So opposite sides are congruent. Number 16, angle DEF, which is right here, is congruent to what? Well, it has to be congruent to angle DGF or angle FGD. Those are the same two angles. Why? Opposite angles are congruent. The last one says angle DEG, so we're doing 18, has to be congruent to what? Well, it has to be congruent to angle FGE or angle HGF or angle EGF or angle FGH. These are all the same angle. Again, a little bit of review on how to name angles. G is the middle letter in all these. That's because it's the vertex. Just trace out the letters and you'll see that angle that I just wrote down. Why? They are alternate interior angles. The lines are also parallel. So remember, if the lines are parallel, alternate interior angles will be congruent. So a couple different things that you need to know how to do here. The following are coordinates of the vertices of quadrilateral ABCD. Determine if the figure would be a parallelogram. Explain your answer. So there's a few things that you would need to do here. To determine if it's a parallelogram by the slope formula, you need two opposite sides parallel. So two opposite sides parallel. And remember, the slopes of parallel lines are congruent. So that would mean that the slope, remember the slope is abbreviated M. Well, that's not a really good thing because you might confuse it with measure. The slope of AC would have to be congruent to the slope of BD. Because those are, I'm sorry, that's not right at all. The opposite sides would be AB and CD. So the slope of AB, where A is 5.7 and B is 13.7. Remember, we said the slope was rise over run. So it was y1 minus y2 over x1 minus x2. So once we have this, we just fill in the numbers. 7 minus 7 over 5 minus 13. It's 0 over negative 8, which is just 0. The slope of CD, where C is 10, 3, and D is 2, 3. Again, we use that same slope formula. This time, this is x1, y1, and this is x2, y2. So whenever we plug those in, it's 0 over negative 8, which is just 0. So we verified that those two sides have the same slope. I'm not going to do this, but this is what you would need to do to finish solving this. Also need to verify the slopes of BC and AD are equal. So you need to verify that those slopes are equal in order to prove that it's a parallelogram using the slope formula. The next thing we're asked to find is the distance formula. So using distance, have to verify that both pairs of opposite sides are congruent. That's what you have to do because that's what our theorem stated. So you need to prove that AB is congruent to CD. And remember, our distance formula is the square root of the difference in x's plus the difference in y's whenever we square both of them. So we have A is 5, 7, and B is 13, 7. All we're going to do is substitute all those numbers in. So we have 5 minus 13 squared plus 7 minus 7 squared. So if we're really careful with our parentheses, we can do all of this at the same time. I always want to make sure that I have the right amount. So basically, I have to make sure that 5 minus 13 is in parentheses, 7 minus 7 is in parentheses, and I see that AB is equal to 8. Now I got to check that CD is the same. So let's change it to blue. C is 10, 3. D is 2, 3. So I have x1, y1, x2, y2. Just plugging it in. So we just use the same trick again where it's not really a trick, we're just entering in what we have. Plus 3 minus 3 squared. And we see that we get 8 again. So those two are equal. In order to prove it's a parallelogram, I'm not going to do this part. You can try it on your own. We must also verify that the other pair of opposite sides, which is BC and AD, are congruent. So that's what we would need to do. We need to do one more step. You can do that one using the same exact method that I used here with the distance formula. The last one says the midpoint formula. So all we need to do here is verify that the midpoint of the two diagonals is the same. That's because the diagonals bisect each other. So if we know that AC and BD, which are the diagonals, are the same point, have the same midpoint, then we're going to see that this is a parallelogram. So the midpoint of AC, A is 5, 7, C is 10, 3. So we have the midpoint is x1 plus x2 over 2 and y1 plus y2 over 2. So a lot of the things that we learned earlier in the year are coming back. So whenever we substitute it, we get that. And it's going to be 7.5 and 5. So we need to verify that this is also the midpoint of BD. B is 13, 7. D is 2, 3. So this is x1, y1, and this is x2, y2. Remember, point 1 and point 2. Midpoint, always good to get more practice writing the formula. You definitely want to remember this. It's not given to you on the SOL, but you'll need it in order to solve problems. So it's going to be equal to 13 plus 2 over 2 and 7 plus 3 over 2. And again, we see that that's 7.5 and 5. Some of you forgot this logic symbol that we learned earlier in the year. The 3 dots in a form of a triangle means therefore. Therefore, the diagonals bisect each other and quadrilateral ABCD is a parallelogram. I hope this was helpful. This video was a little bit longer than most. There's a lot to take in here. Um, but hopefully you just know those 6 things about parallelograms. That's all you really need to remember. Again, none of it should be that surprising. Whenever we draw a picture of a parallelogram, we kind of see that all those things are true. That the opposite sides are parallel, both pairs of opposite sides are congruent, both pairs of opposite angles are congruent, each pair of consecutive angles is supplementary, the diagonals of a parallelogram bisect each other, and one pair of opposite sides of a quadrilateral is both parallel and congruent. Those are the qualifications we need to prove that a quadrilateral is a parallelogram. Please come to class prepared, and we're going to be doing a lot more practice in class.